In this tutorial we'll focus on just a couple of ideas, and they're the ideas that all the continents of the Earth were once joined together into a supercontinent called Pangaea, and the idea that these continents over time have drifted apart on a number of continental plates, and this will lead us into looking at plate tectonics. So first of all, let's have a look at this idea that in the past there was a supercontinent called Pangaea. This idea was originally proposed by a fellow called Alfred Wegener, who lived between 1880 and 1930. And he proposed the idea that once all of the current continents were much closer together and joined. So you could almost imagine the continents of today as a jigsaw puzzle, and it's fascinating that when they're lined up like they are in this diagram, you can see, like a jigsaw puzzle, they look like they should naturally fit together. And this was part of the reasoning behind the idea that if you go back far enough in time, that in fact all the continents were very closely joined together and formed a supercontinent called Pangaea. Over time, these continents drifted apart on the tectonic plates, which we'll have a look at in a moment, and became a northern supercontinent referred to as Laurasia, shown here, and a southern supercontinent that was referred to as Gondwana. So Gondwana, or Gondwanaland, is shown in more detail in this particular picture here, and it was comprised of today the continents we refer to as South America, Africa, Arabia, India, Antarctica, Australia, New Guinea. We're all joined in this southern supercontinent. But of course, even now we would recognise that these continents are no longer joined together, which would suggest that these continents have in fact drifted apart and continue to drift, as the plates that they're sitting on, the continents are sitting on, are floating on molten rock and are actually moving. So let's have a quick look at how this would take place. Let's now have a look at the main features of this theory of plate tectonics, which seems to explain the movement of the continents, which can now be measured very accurately using GPS, global positioning satellites, which is the same technology we'd use in cars when you have a GPS or on your phone that helps to position you or know your position exactly on the planet. So what are the principles behind this? So first of all, the Earth's surface is covered in a series of crustal plates. So we would see that these various crustal plates are floating on molten rock, which is very, very thick and moves very slowly, and these plates will float on that particular molten surface. A second principle here is that the ocean floors are continually moving, and they're spreading out from the centre, as we can see in this diagram here, and sinking at the edges, as we can hear. So in subduction zones, parts of the seafloor sink back down, and then with convection currents, with cooler material sinking and hotter material rising, then we see this kind of movement as seafloors rise and fall, and this causes some of the movement of these crustal plates. The heat that's driving these convection currents here comes from radioactivity deep down in the Earth's mantle. So let's just pop those principles down. So we have number one, that the Earth's surface is covered in crustal plates. Two, that the ocean floors are moving. And three, that there are convection currents that explain the movement of the plates, and fourthly, the heat to drive these convection currents comes from radioactivity deep in the core of the Earth. And this picture here gives you a very good representation of the various layers of the Earth that you've looked at in this unit. And you can, if you want to pause the tutorial here, you can get a good understanding of the various layers that make up planet Earth. So on the outside you have a very thin crust, the crust under the land, and the oceanic crust, which is the crust under the ocean. So in these two areas here. Underneath the crust you have the mantle, which is made up of very, very dense but liquid rock. Underneath this you have the liquid outer core here. And then right in the middle of the Earth, the solid inner core. And although it's incredibly hot in the middle, there is such pressure from the forces of the Earth around it that it compacts the rock into a solid form. You can also see the various distances that make up the various layers of the Earth. To finish this tutorial, let's just focus on a little bit of the history and some of the evidence for plate tectonics and continental drift. Basically, the theory of plate tectonics is a comprehensive theory that explains how the Earth works, and it was formulated in the 1960s and 70s, and the theory was built on information about the nature of the ocean floor and how it forms and how it grows, about evidence from ancient magnetism, evidence from the distribution of volcanoes, evidence from earthquake activity. There's magnetism in there, and evidence from about measuring the flow of heat from the Earth's interior, and also looking at evidence from fossils and how they're spread across the world. So all these things were strong evidence pointing to the idea of plate tectonics, and the idea that the continents are floating and are moving on multiple plates as shown in diagrams such as this one. And so basically the theory states that the Earth's outermost layer is broken into 7 large rigid pieces called the plates, and they're the African, North American, South American, Eurasian, Australian, Antarctic and Pacific plates are the key ones. And what's interesting to note is that the plates, as I said earlier, are still moving and it can be measured, and they tend to move somewhere between about 2 centimetres up to about 10 centimetres per year, about the speed that an average fingernail grows. And as the plates move around, there's a number of things that they can do. I'll have a quick look at that. So the possibilities are that they could crash into each other, they could sideswipe each other, so glance off each other. So you might have this kind of effect. You might have 2 plates that collide with one another, or you might have plates that, as they move, pull apart from each other. So they can sideswipe or pull apart. And often where they're colliding, mountain ranges can form between them. A classic case here is the Himalayan mountains, the tallest mountains in the world, that are still rising as the 2 plates crash into each other. The place where the plates meet is referred to as the boundaries. So in here are the boundaries. There are 3 different kinds of boundaries. So where you have continental plates that crash into each other, such as here, you will have convergent boundaries. Converge means to move together, to move closer together. So convergent boundaries, where the continental plates are pulling apart, you have a divergent boundary. Divergence means to move apart. And where the plates are sideswiping each other, as in this case, you have what are called transform boundaries. So 3 different kind of boundaries depending on what the continents are doing. So when the continents are colliding, as in this scenario here, the boundaries are convergent boundaries. where the continents are pulling apart. Over here you have divergent boundaries, and where the continents are sideswiping each other, you have transform boundaries.